Good to go? Okay. Hello, everyone. Thanks for joining us today. I am Amanda Quinto, and I am a solutions architect in Brazil, responsible for public finances for the past 6 years. Today, we're going to talk about a little bit secure AI agents in delivery efficiency in high regulated environments. I'm here with two really nice customers, Edson and Andreas. They are over there, and they will be presenting with me today. So again, thanks for joining. It's really nice to be in re:Invent this year with you guys. There's a little bit about our agenda. So we are going to talk about high regulated environments and how we can operate AI workloads on top of those kind of environments. And then we are going to talk about how we can use Amazon AKS to run AI agents and AI workloads on AWS. Edson will explain how is Sicoob using these kind of environments to run workloads for Gen AI in high regulated environments. We are going then to move to Amazon Bedrock and understand how can Bedrock help us to deliver AI agents and also stay inside of our regulations. And then Holland Casinos, represented by Andreas, will be showed here for you guys to understand how they are using Agent Core to run their workloads on AWS. Okay, so let's get started. We have about 1 hour here, and I will try to make you guys up. I know it's a really heavy event, and you guys walk a little bit long distances to be here with us today, so thank you again. When we are talking about high regulated environments, we are no longer just thinking about deploying models on AWS. We need to operate inside of dense amounts of laws, standards, and patterns to stay inside of the regulations of our current countries. Here we are representing two different countries, that's Brazil and Holland, but we can see these movements all around the globe. Europe, for example, has the Europe AI Act. That is a movement with strict risk-based framework that bans some uses completely from AI, and also determine some different obligations for high-risk systems to run both on cloud or in the on-premises environments when we are talking about data and AI workloads. Brazil is combining their emerging AI legislations with the legislations that they already have on top of data, something like LGPD, for example. We also took two different patterns. We have some obligations that's federal for mostly data from public sector, for example. We should stay with this data inside of the Brazil, and we also have some discussions around data sovereignty, and we also have some determinations around specific industries. So, for example, my industry, finances and public finances, have some obligations that is determined by central bank. So we received the normatives from central bank, and we should make our customers to run inside AWS respecting these kind of obligations. This is a worldwide movement. We have today more than 1,000 different AI regulations around the world, and this is representing more than 69 countries. So it's not easy to stay inside of the regulations as a provider such as AWS. So we work specifically in each customer cases to deliver the best architectures that fulfill these kind of requirements. There is something common when we are talking about this kind of frameworks and obligations. When we look into Brazil or South America or United States or Europe, there are always some pillars that is similar in different scenarios. So we have compliance and governance, we have legal and privacy, controls and risk management. These 4 pillars always appear in different normatives and regulations around the globe, and that can make for us the bottom layer that we can look into this and deliver different architectures that work for mostly cases around the globe. But again, there's different obligations in different countries, in different industries, that we need to always make sure that we are responding correctly for this kind of environment and obligations. So there is some patterns that we can follow so we can understand the customer needs, the regulation needs, and stay on top of these kind of obligations. We can see this in a layered pattern that can help us here. So we have, at the bottom, we have the Gen AI application, for example. On top of this, we have regulatory layers. So as I said, it's different from each country. It's different for Europe. It's different for Canadians. It's different from Chile and China, for example. And we need to be specific here. But there is other layers that we can understand in a broader way. So for example, when we're talking about responsible AI, and in AWS, responsible AI is a really heavy pillar that we are following from our customers and also our services to deliver Gen AI solutions for the customer. So when we talk about responsible AI, we have some pillars and patterns when we talk about data, when we talk about safeguarding our customers, when we're talking about security and prompt engineering structures that we can be aware of malicious users, for example. So all of these kind of discussions are inside of the responsible AI layer in AWS. So this is a really interesting content that you guys should, if you guys like this kind of documentation, it's a really heavy documentation and you should read about it because there is a lot of good instructions over there. And if you follow the responsible AI patterns, you're probably going to be inside of the obligations in your countries. We also have compliance and standards, and here we are talking about ISOs. We are going to talk a little bit further about ISOs, but it's important to know that there is specific ISOs for specific Gen AI workloads already. So we are also looking to this, and we are also delivering architectures on top of it. And here we are talking more the technical aspects here. So it's a layered approach. So we have the bottom layers on the regulatory, and on top of this, we can think about more technical perspectives. So we can see NIST framework, for example, NIST 600 framework, for example, is a risk management framework for AI. But as you know, NIST is just a pattern that we can follow. They don't really audit your environment for this, but we can look into this framework and see if we are architecting our systems on Gen AI following these patterns. And then when we are going to suffer some auditation from the responsible government or something, we are going to probably be inside of these obligations. Okay, so NIST AI Framework 600 is a really good framework. It's the main framework that the United States is following for their obligations and the laws and definitions that you guys are following here in the US. On top of this, there is OWASP. So OWASPs are really common when we are talking about, for example, OWASP top 10 vulnerabilities for security. There is also the OWASP LLM AI security, cybersecurity pattern. So you can see it's improvement, actually, it's being improved, actually, but you can see what is the most common vulnerabilities that can appear in Gen AI workloads. You can see how we can achieve some techniques to avoid this kind of problems. So OWASP is always a good idea. There's also OWASP top 10 vulnerabilities for LLM applications, so you should also be aware. And there are also changes because it's really new. So we are always having new vulnerabilities here. It's not a good thing, but it's a pattern in the marketing. And on top of all of this, we already have the AWS well-architected framework layer for Gen AI applications. So you guys should know the AWS well-architected, I believe. And we have a bunch of different layers for our 6 pillars, and there is already a layer for Gen AI workloads as well. So it's also it's a live document. It's being improved as well, but it's already live for our customers to follow. Okay, so this layered regulation and controls should help us to build this kind of workloads on AWS, following and maintaining ourselves inside of the regulations from our countries, right? Regulatories should not stop the AI adoptions. We think regulatories requires AI adoptions. We can also improve regulatories obligations using AI. We can use AI to understand the regulatory and then accelerate the AI workloads on high regulated environments. Okay, we can see this in government in Brazil. We see this in financial sector. We see this in health sector as well. So we can also we can make them work together. One should not stop the other, right? Okay, so now we discuss a little bit about how high regulators works around the world, how AWS positions themselves on these matters. Let's go dive deep into the technical perspective now. When we are talking about Gen AI in AWS, there is 3 layers, and you're probably going to see this slide a lot on reInvent. I'm going to be real quickly here because this is probably the most used slide for the AWS solutions architects around the world. But this is the AWS 3-layer for generative AI stack, okay? So from the top to the bottom, we have the Q family, so the applications family. We have the Amazon Bedrock, that is our suite, our solution for all Gen AI workloads running. We can use different models. You can use everything on top of APIs on AWS. And in the bottom here, we have the infrastructure layer. So we are going to talk more about the infrastructure layer here because of the Sicoob use cases, and then we will detail this for you. The infrastructure layer here, there is, 2 names here that makes a lot of noise in the marketing. There is training and inferential. They are chips specifically developed by AWS for machine learning workloads. We also have SageMaker, and in SageMaker there's a whole world of solutions. You can deliver different kinds of models using machine learning or Gen AI models if you want to. But we are going to talk about specifically GPUs workloads here. So in AWS, we have a bunch of different types of GPUs. There is a disposability of a lot of GPUs on our stack, and you're going to understand how we can use GPUs to deliver Gen AI solutions for high regulated environments, okay? But in the heart of Gen AI, there is a model, right? There is some commonly used models here. But before thinking about the model, you should understand your use case. So what I'm trying to solve here, what's my pain that I needed to solve with Gen AI, and check if there is actually a Gen AI solution that I should use for this pain, for this problem in my company. Yes, it makes sense to use Gen AI for this kind of workload. All right, so then you should find a model for this. There's a bunch of them in the marketing. We have also Amazon Nova on AWS. After this, you're probably going to use 2 or 3 models for your workload, and you will probably going to change this after a while. Weeks and months after months, we are seeing different models arriving in the marketing, and one is better for one thing, the other is better for another thing. You should not be in love with your model. You should use the best model for your use case. But there's a bunch of them out there. You choose 2 or 3 that works better for your use case, for your scenario, and go ahead. So you use a foundation model. You can both use it RAG, for example, or prompt engineering to solve your problem. And just to make one quick comment here, this is a 300 session, so This is a 300 session, so we're not going to explain what's RAG. We're not going to explain what is a prompt engineering, but we are going to stay all of the events here, the solutions architects, to help you with that if you have some doubt, all right? So you choose your model, you have your problem solved. You need to understand if you're going to use, for example, prompt engineering or RAG to make your data inside of this model or in parallel with this model. That should work for you too. If that doesn't work, you can fine-tune your model. So there is a model, you can get your data, your specific data for your specific industry, and fine-tune your model to fulfill your use case to solve your problem. That works too. It's not an easy task to do. You need a lot of data to do this properly, but it works well when we are talking about specific industries. For example, in Brazil, we are seeing a movement of financial sectors using this, health sector using this, and also public sector. The government is thinking about developing and fine-tuning the large foundation models with specific data. So that should work for some large use cases here, but it's not an easy task to do, and you need a lot of data. Or you can train your own model. For this is really is a heavy task to do as well, but should work. You should have a lot of data again. You should use a bunch of GPU to train your models, but that works as well. So you need to understand which approach is better for your workload, for your use case, for the size of your company, and then move forward. We have a model. Now what we can do? We need to do the inference. So in the heart, there is a model, but we need to deliver this model for our application in a way that we can do predictions, we can do run prompt engineering on top of this model faster, easier, with low latency if we are talking about some production workload, for example. You can also do batch predictions, but you also need inference endpoint that is generally available, that's resilient, that's secure as well for your workload. So this is important here. In AWS, there is 3 different ways to do this. We can use Amazon Bedrock, and we are going to talk about this a little bit further. You can use SageMaker as well, so there are specific models that you can deploy on SageMaker, and you can also deliver endpoints for making inference on SageMaker, and you can use Amazon EKS. There is a really interesting movement running right now, and we are seeing this growing on the AWS with Amazon EKS. So if you search for do on EKS, data on EKS, there's a bunch of interesting materials. We have a bunch of customers using this around the globe. But to use Kubernetes as your main platform, you need to understand that this is there's an overhead on top of your infrastructure team here. So if you already are using Kubernetes to run other kinds of workloads, to run your workloads in production in AWS, your team already know this solution. That's probably a path to go. But if you don't know Kubernetes as well, you don't know Amazon EKS, and you're going to discover this while you are trying to implement generative AI workloads on AWS, that's probably going to be a hard task to do. But I am a really fan of Kubernetes, and if you are doing this, you're probably going to get some really outcomes after all the overhead on your team. Okay, so when you are using Kubernetes as the main platform here, we probably going to already have some main pillars for production workloads on AWS, such as disaster recovery, cost visibility. We can have deployment automations as well on Kubernetes. And we can also deliver and deploy our inference endpoint and our generative AI workloads on Kubernetes. So instead of deploying Amazon EC2, for example, with GPU and run everything inside of this EC2 and have problems with scalability and have problems with deployment automations and disaster recovery, you can put this inside of Kubernetes with Amazon EKS and then run your Gen AI workloads in this kind of architectures. Okay? I'm talking a little bit more than I used to, and it's really cold in here, so I'm going to take some water here, but let's keep going. So why customers choose EKS for inference, as we were discussing? There is a bunch of good things, such as disaster recovery, scalability, cost predictions as well. We can have some tools for this. But for me, the main reason is for open source ecosystem. So the open source ecosystem for Kubernetes has been really good, really dense material for the past, I don't know, more than 10 years for different kinds of workloads, and for Gen AI workloads, this isn't different. So there is a really good materials for Kubernetes Gen AI workloads with the open source community. They are always developing new solutions for this. So when this started, I don't know, maybe 1.5 years ago, we didn't have solutions for deploying clusters with GPU. We didn't have, for example, images that was GPU prepared. We didn't have infrastructure as code solutions for this. But 1.5 years later, we already have some projects that is really mature, an open source ecosystem that supports these kinds of workloads all around the globe. So again, if you guys like this kind of materials, you should search for data on AKS. There is a bunch of interesting materials over there. We also have all these pillars here for the reason to choose Kubernetes. For me, the open source ecosystem is the most interesting one. You can also run this everywhere. So you can run this on AWS, you can run this in different providers, you can run this inside of your own infrastructure. If you have, for some reason, you have GPUs over there, you can make some tests on your on-premises environment, for example. So there's a bunch of different reasons here that we can use EKS. And now Edson will share a little bit of the Sicoob case with us and how they are using this kind of architectures to fulfill their business needs. Okay, so Edson, please. Thank you.
Thank you, Amanda. Hello, everyone. As Amanda said, my name is Edson Lisboa. I am IT executive at Sicoob, and Sicoob is one of the largest cooperative financial system in Brazil, the credit union in Brazil. And it's my pleasure to be here with you today during the next few minutes to share on the reInvent stage, to share a little bit more about our generative AI journey and how a highly regulated financial institution is successfully adopting generative AI at scale, keeping security, governance, compliance as non-negotiable pillars. So let me start with who we are. As I said, Sicoob is a cooperative financial institution in Brazil, and Sicoob is present in all over the country. As you know, Brazil is almost a continental country, and Sicoob is present there. And Sicoob offers almost the same financial products and services as a traditional bank does. Sicoob is present in almost 2,500 Brazilian cities, and it's very interesting to emphasize that over 400 Brazilian cities, there is only Sicoob there. We have more than 300 credit unions integrated with our cooperative system. We have 14 central co-ops, and we have 4,700 branches in all over the country with more than 60,000 employees. All this structure serving more than 9 million people in our country. And it's very important to emphasize that even considering this presence in our country, over than 98% of our transactions are performing on our digital channels, such as mobile app and internet bank. And as a financial institution in Brazil, it means that we are living under a very strict regulation from our Brazilian Central Bank. And for us, governance, it's not only a compliance checkbox, but it's really a true competitive differentiator. So we decided to create a centralized structure to control the decisions about governance with clear accountability, risk classification, and continuous monitoring. And when we started our generative AI journey, we defined 4 unbreakable pillars, such as the first one, security. As a financial institution, for us, the security of our credit unions and members' data is our priority. The second one, scalability. Considering our actual numbers, as I had showed you, and considering our goals for the next few years, we really needed an environment and a solution to support our size and our growth needs. So it was very important to us. The third one, efficient cost management. It was very important to us run the large models considering the strategy pay as you go and considering the strategy related of open source LLM adoption. It was very important to us too. And last but not least, multiple LLM models. We wanted to use the right model to the right task. We really believe that only one model doesn't fit all needs. And these are the open source LLM models that we are using. We are running on AWS using Amazon EKS, as Amanda said. And the models Llama from Meta, Mistral 5.4, the Chinese model, DeepSeek R1, and the model from IBM named Granite. Sometimes we are using multiple models side by side in the same use case. And in other cases, we can choose a specific model considering the fastest or considering the most accurate to that subject. And considering all this strategy and this information, Ms. Amanda will explain a little bit more about technical informations of our environment. Amanda, help me.
Yeah, thank you, Edson. Thanks for sharing. Okay, so again, we have a model, as Edson said. They choose their model, they choose their problem, what they are trying to solve with generative AI. They understand the regulated environment and what obligations they should achieve. And this is the architecture that they are running on top on AWS to solve these problems. So we are going to discuss a little bit about this architecture here. It is actually a simple architecture. In the core of this, we have an Amazon EKS cluster, okay? In Amazon EKS cluster, we are deploying EC2 instances with GPUs. To do this, there is a bunch of best practices that we are discovering with our customers from the past 1 year and a half or so. And we are trying to bring it here for you guys when you're going to try this on your specific cases. So, for example, you guys should think about using specific AMIs for generative AI workloads, for GPUs workloads. So there is, for example, drivers from NVIDIA that you don't want to deploy it by your own. There's a bunch of different versions that that you can have some problems when you are deploying this, so use specific AMIs. Other good idea is to download all the models for Amazon S3, for example. So instead of downloading the model every time you run a new pod inside of Kubernetes, you can use this on Amazon S3, and it's really quickly to deploy it on EKS when you already have the model here. Okay, so this is a good idea when you are deploying this kind of infrastructure. But actually, this isn't a Kubernetes presentation, so I'm trying not to go so dive deep into the Kubernetes perspective. But there is two open source solutions that's really helping and making this workload make sense for this workload on Sicoob. So we know GPUs are expensive. They are not cheapest infrastructure. We know this. So they are using Carpenter to scale Kubernetes with GPU instances on AWS. So instead of just deploying the instances based on this model needs this shape of GPUs, I will deploy my cluster with these node groups, and that's all. They are using Carpenter to do this using spot instances on EKS, on Kubernetes. So instead of just leaving the GPUs over there without utilization, they pay as you go, as Edson said, and use these GPU instances based on their needs. But there is another solution on top of this that is also an open source solution that is KEDA, that's for the growing. I'm trying to not use Kubernetes concepts here, to scalability the pods inside of the cluster. So whenever they received a request from the environment, so if they are not using the final users, they have both inside users and customers using this environment, but the users are not using the environment, they don't run any pods, so they don't deploy any GPU instances, so they don't pay for it. So the KEDA is used to scalability the pods based on the request. So we receive the request in this environment, then we will deploy it for the end user. It's something that you think about it because it took some time to deploy it. But if there isn't, transactional workload that's running inside of the cluster, maybe the customer, the end user or the final customer can wait, some seconds over there to deploy this, to then start using the generative AI model or something like this. So this works better for Sicoob, and that's why these environments make so much sense. With this kind of architecture, combining Carpenter and KEDA using EKS clusters, they can deploy different models, they can achieve different business cases using this environment. So there is a bunch of different cases here, Edson will explain for you a little bit later, inside of the same cluster. So the same cluster is running this. To operationalize this, they are using other two open source solutions. So as I said before, that's one of the core reasons that I believe that Kubernetes makes so much sense for Gen AI workloads. the open source solutions. I already talked about two. Carpenter, it's developed by AWS, but it's an open source solution, and Keda. There's also another two. So we have Light LLM. So instead of managing these models inside of the cluster, I don't know, in command line, we can expose this for the final users using Light LLM. So this is also an open source solution. It's also some how-tos, how to deploy this on AWS in our documentation. It's a really nice solution that you can use to manage all these models inside of the cluster. So we have a customer interface, an end user interface that you can run the models. And also VLLM. VLLM is a solution that is actually new in this environment, in Sicoob environment. Before this, they were using a Llama, but they achieved that using VLLM, they have much more, it is much more faster, it's more compute optimized to run the models. And VLLM is actually a new solution, a new open source tool, and is receiving improvements from the community. So it's probably going to be even cheaper than we started using this kind of engine to run LLM models on top of Kubernetes. So this is here 4 open source solutions that really make sense for them to run this workload, to run different kinds of workloads inside of the same cluster here. And then we can also use other AWS services around this. So for example, we have Amazon ECR for the images. We are using Ingress to expose the endpoints of the models for the solutions with AWS load balancers and other solutions. But the main of the infrastructure of the architecture here is inside of the cluster. So this kind of solutions is really making sense for this workload for them. And also deploying GPU instances on AWS. When we use Carpenter, we don't need to work on the heavy lift of thinking about which different instances there is available in this zone, for example. You can put 3, in Brazil we have 3 zones. We can put those 3 different zones inside of the Carpenter manifests and say, I should use these shapes of GPUs. Which one is better, which one is available, and which one of these is cheaper, you should deploy it on the cluster for me, and then let Carpenter works, he does the works for you. You can use budgets on Kubernetes to arrange the way that they took off your instance, but they only took off your instance, or your spotting instance, after you have another one deployed, so there is some ways to work with spot interruptions when we are talking about Kubernetes environments. So there's a bunch of solutions and tricks and tips here that we can understand how we can operate generative AI inside of Amazon EKS cluster on AWS. Okay, but the main idea here is that we can run different workloads inside of the same cluster with cost management achieved. We are being able to run this with some low overhead on top of the team. Okay, so Edson will now explain which are the outcomes and what are the business solutions that they are achieving.
Thanks, Amanda. And now for me is the most important part, considering the real use case and considering the business results using all these platform, all this environment, using these LLM models as Amanda showed to you. First of all, I would like to share a little bit about our internal intelligent development assistant named SysBR Code AI. SysBR is the name of our core bank platform, and we decided not to pay or not to buy a specific solution to integrate to our platform. We decided to create our own solution using these LLM models that I showed you, and we integrated this solution with IDEs of our developers. Nowadays, we have almost 1,500 developers in our company. And there are a lot of benefits of using SysBR Code AI, like automate code insights, automate code recommendations to the developers, Accelerate the process of onboarding of new developers was another benefit. Saves time to deliver new features and new solutions to our credit unions and our members, and not only save times, but also improves the quality of our solutions, and continue support throughout the development cycle. The second one, our back office automation. Nowadays, we have almost 8 digital robots automating manual tasks, and not only simple manual tasks, but complex manual tasks too. And it's the reason that we are using generative AI integrated with our robots, AI agents. And it was possible to save almost 400,000 human hours with this kind of solution. Another interesting real use case is our investment advisor. It is a specialized support for investments using generative AI, and it's possible to create good recommendations about investments to our investors, considering the member profile, considering the best market practices, and for sure considering our products, investment products offered by our credit unions to our members. It was another very good solution to our business every day. And last but not least, I would like to share about our core bank smart assistant named SysBR AI. There are a lot of features in this solution, and it's possible, such as it's possible to interact with documents, not only normal documents, but legal documents, contracts, and it's possible to interact using natural language and get good answers using generative AI. And it's possible to do intelligent search, and it's possible to create analysis and generate automatically credit loan decision reports using generative AI using this solution too. And finally, I would like just to emphasize that there are a lot of other benefits and results for the business considering these use cases using generative AI and other use cases that we have. And it is a good option for our business using this kind of solution. So thank you for your attention, and Amanda, stage is yours again.
Yeah, thank you, Edson. Thanks for sharing. Thanks for sharing the Sicoob journey. For me, it's a pleasure to be here with Sicoob. We've been working together for the past 6 years in AWS with Sicoob, so it's a really nice case. Thank you, Edson. Thanks for your presence. But okay, let's dive to the second part of the presentation. So we were talking about high regulated environments on top of Amazon AKS and GPUs infrastructures, and now we are going to talk about how we can build AI agents on Amazon Bedrock, also covering the regulations perspective, okay? So let's go again in the most used slides in the reinvent. So we have our tree layer here, and now we are going to talk about the middle layer. So Amazon Bedrock is a tool focused on builders and developers. So we are using building blocks to deliver generative AI solutions for our customers. We start just, I don't know, maybe in 2023, I believe, just with some models and some endpoints for our customers based on APIs, and now there is a fully completed solution that hosts models but also covers guardrails, security, prompt engineering, prompt caching. There's a bunch of different solutions that you can use on top of Amazon Bedrock. Okay, so we are here to talk about high regulated environments again, and we start talking about ISOs, and I said we are going to return on this matter further in the presentation, so now it's the time. When we are talking about Amazon Bedrock compliance, there is a bunch of different regulations that we are already achieving. So there is different ISOs as well. We have SOC 1, 2, 3, we are IPA eligible, and there is a different kinds of regulation for different kinds of countries. But there is one specific ISO that I would like to highlight here, so is the ISO 42001, and it is specific for generative AI workloads. And AWS with Amazon Bedrock was the first provider to get this ISO. So this is a real interesting thing for when we are discussing this kind of high regulated environments, and this ISO is a really important thing for the product, for the Amazon Bedrock. But the most common question that I receive with my customers and in events around data and AI concerns is about the data. So I would like to highlight here that customer data is not used for AWS to improve any foundation models, and the customer data is not shared between the other customers. So your data is isolated, and AWS doesn't use this to retrain models or to improve the bedrock. Okay, so this is really important when we are talking about every environment, but for high regulated environments as well. Going forward, so you can also choose which model you would like to use. So there's not a black box where you have an endpoint and then you send your data and you don't know which model you are using. You choose the model that you want to use. You also put the correct permission for your developers and builders to use those models inside of Amazon Bedrock for your specific region. So this is also important here, okay? It's your choice which model you're going to use, which size of model you're going to use, which region you're going to use it. When you put your data in a specific region on AWS, your data remains in this specific region. For some countries, as Brazil, this is really important. We have some regulations around data that remains inside of Brazil, the country of Brazil. We cannot take this data from the public sector of Brazil. So this is important for our customers, and we'd like to highlight it here, right? But you can do cross-region inferences if you want to. So for example, you are using Amazon Bedrock in Europe, and you'd like to have more latency, for example, for your models. You can use different regions for this, but it is your choice which region you are going to use. So for example, if you are in Europe and you are based on Europe AI Act, you can use data inside all the Europe, not only one country, one specific country. So you can create inference profiles inside of Bedrock with specific countries that you can use it, and then make cross-region inference for your data based on your regulations as well. So this is your choice. This isn't made by default on Amazon Bedrock, but you can use it to improve the performance, but staying in your regulated environment, right? But let's talk about Amazon Bedrock Agent Core, all right? So over the last year, we've seen AI evolves from assistants to agents, right? So now agents is the hype of the moment. The main difference here is that when we are talking about agents, we are talking about a solution that works autonomously. So it's not task-defined, it can work autonomously. You can create your own agents using open source solutions, for example. And I'm going to let Andreas talk a little bit how you can do this and what is the heavy lift on top of it. But AWS understood that this is a need from our customers, and that's why we deliver Amazon Bedrock Agent Core for the customer. So if you guys doesn't know Agent Core yet, you should take a look into it. It's a really nice solution, a really nice service. We are probably going to have a bunch of new things in reInvent in the next month. Is a really new service. But here, let's highlight some parts of the Amazon Bedrock Agent Core that works for high regulated environments and that can help you to stay within your regulations, okay? So we have Agent Core Runtime. So you can run and host your agents purpose-built. It's serverless, it's totally serverless, you don't need to deploy any infrastructure inside of AWS, but each session of your agent, so you're defining some tasks for customers, specific customers, so for example in financial sector, you have a customer that is running one solution inside of the internet banking, you can make each session isolated from one to another. This is really important for regulated environments, and Amazon Agent Core does this by default when you are using Agent Core runtime. So this is one interesting solution on Agent Core for high-regulated environments. The other one is Agent Core Identity. So it helps you to maintain secure your authorization, authentication, and credentials for the customers. So it's by default, you can put the credentials for the customer or in any kind of authentication flow inside of Agent Core, and he will remain isolated and can keep this secure for you. So it also helps when you are deploying, developing your own agents on AWS. Okay, we also have sandbox environments for code interpreter and browser tools. You can also do this inside of Agent Core without needing to developing anything or deploying anything. It's a solution, it's a service that is inside of Agent Core, and you can just arrange which kind of code interpreter you want to use or which kind of browser tool you want to do inside of the whole mechanism of Bedrock with security, with authentication inside of AWS. So there's a bunch of other solutions in Agent Core, but I would like to highlight these three because it's for the high regulated environments. It could be useful for you guys develop your agents on AWS. Okay? So going forward, when we are talking about LLM models, there is also a discussion around which data was used by this model to train. How can I know if this data has bias or not, if it follows what I believe is correct for my company? I would like to highlight here the Anthropic system card. So I don't know if you guys have heard of it. You should read. It's a really interesting reading of 140 pages probably, but you can read it. It's really interesting, and it explains how it was trained and why is this trustworthy. Okay, so Anthropic is doing a real good job inside of the transparency of how they train their models and which kind of data they are using. We also have AWS scorecards for Amazon Nova, so you can see this on the documentation of the Bedrock and the Nova model, and there's also a bunch of information over there of how they were trained and which kind of data they are using and what, AI responsible that we were talking earlier. There's also described for Amazon Nova in these service cards, okay? But even when we are talking about all these different perspectives of AI, of regulated AI, LLM models are a non-deterministic technology, okay? So you can also use guardrails from Amazon Bedrock to stay within what you believe is the correct answer for your end users, all right? So don't believe that the models will always write the same thing. He won't. You should be able to prepare, to define your architecture on top of this, using solutions such as guardrails to stay within what is correct for your end user. When you are using LLM solutions for end users, this is really important, okay? So you can also be aware of what the model is going to respond, and also prepare for those malicious users that we were discussing with OWASP 10, for example, the different kind of uses for Gen AI for cyber attacks. You can also use AWS guardrails to help you with this kind of issues, okay? Sorry. All right. So now I will ask for Andreas to join me here. He will explain how Holland Casino is building their agents on AWS. Andreas, please.
Thank you, Amanda. We're running about 5 minutes late, but I'll share very useful tips at the end, so please stay. They are very important. My name is Andries Kreitenberg, and I do indeed work for Holland Casino. It might surprise you, but Holland Casino was started by the Dutch government about 50 years ago with a clear mandate to offer a safe environment for players. Currently, we run 13 casinos in Holland and 1 online casino. We operate under a very strict gaming oversight through the Dutch gaming authorities. This centers around player safety and detection of fraud and money laundering. Now, the stakes for us are very high, right? If we fail to meet these regulations, casinos will close until compliance has been restored. We will suffer reputational damage. We have a very strong brand name, even by people that do not play. Financial penalties, they are seriously high. It's more than a headache. And we face possible license suspension. So apart from meeting these regulations, we have other problems as well. You see, regulations are subject to political decision-making, change frequent, sudden, and with fixed deadlines. Sometimes we have 3 months, a month even to change things. Now the casino depends on third-party applications for gaming concepts, gaming machines, jackpot concepts, casino management systems. And the problem is that these third parties cannot move fast enough as we like them to. So we, Holland Casino, need to have an environment where we are in control and have rapid response capabilities. And that's where we ended up in Amazon Cloud. In Amazon Cloud, we build our regulatory flows, our regulatory reports, and our regulatory alerting. And we do this since 2017. And we do this with a very group of very talented colleagues of mine from not only technical people like testers and developers, but everybody, like architects, product owners, IT managers, and we are assisted by colleagues from Easy to Cloud. Now, over the years, as a team, we really have to come understand Amazon Cloud very well to implement our regulatory use cases. It's a growth period. Now, our success and internal belief in AWS has seen us grown in Amazon Cloud with more workloads. So now we host our central casino management system, business intelligence, data analysis using SageMaker, and even our legacy enterprise bus we host in the cloud on EC2 because of its stability. Now, why am I telling you this? You see, well, our business culture, and maybe many of yours as well, is to start small with an architecture, gain confidence with it, and then build up the capacity to execute regulatory use cases. And this is exactly what we want to do with our AI architecture. We want to start small, gain company-wide confidence in the technology, and then grow and eventually have agents assist us with regulatory use cases. So briefly, our journey so far in Gen AI. About a year ago, we started using code generation with the Anthropic models in Bedrock. Then we looked at Bedrock agents. In Q2, Q3, we started looking at Strands agents. And those we really liked because they're really simple, and I show you later on. Then we started evaluating Amazon Bedrock Agent Core to host these agents on. I'll show you that as well. Agent Core just came out of preview, and we're right now busy putting them in production. So we've been looking for a small but important use case, and we found this in what we call the management insight gap. You see, management is always in need for cost, security, and compliance oversight. They will not log into the Amazon console to get the data. It is not the right tool for them, right? So management, stakeholders, especially the security department, came to us, the internal team, my team, to provide them with ad hoc reports. And we created many Python scripts to provide these reports. And this creates an unnecessary dependency, and it does not scale. Now, the scripts that we write for these ad hoc reports, they come back later when we talk briefly about Strands agents, so keep them in mind, right? So as a first use case, we give management and stakeholder agents that give them information they need on a self-service basis. And because we start off, these are single agents. We're not yet busy with orchestration. Yeah? These agents center around cost, security, and operations. And they can have a dialogue with them. That is very important, right? We use Strands agents. Why? They're very simple, and I'll show you in the next slide. They come packed with tools that you could use, but it is very easy to integrate your own tools and your MCP servers. It is Python-based, we're a Python shop, so it's easy for us. And it is open source, so you know exactly what is going on. And this is a Strands agent. Yeah. In the middle, I declare my agent. I give the model, in this case a Bedrock model, and Sonnet 4.5. And I give it a system prompt. Normally we craft a system prompt, it's quite long, we spend quite a lot of time creating our system prompts, but for space purposes I redacted it here. And then I give it a tool, in this case a billing tool. Now remember the scripts I was talking about earlier on, these ad hoc scripts. it turns out that it is fairly easy to transform them into tools for your agents. So don't throw the scripts away, right? Just make sure that you write your system specification or your tool specification really well. That is really, really important. Now, I had an ad hoc report for billing, and I transformed it into a tool for my Strands agent. And once I've set it up, I can invoke my agent. I can say like, well, what are my costs so far this month, right? And then it gives an answer. And if you use sessions IDs, you can delve into it. You can have a dialogue. You can ask like, well, what were my costs? What was it compared to last month? Or I can delve into a service. So you have a dialogue, and this is what we want to give our stakeholders. Okay, you got your Strands agent. It works on my machine, and I can guarantee you it works on every one of yours machine. It's easy. However, we need to give it to our stakeholders, right? So we need to host it in Amazon Cloud. We want it to scale, we want it serverless, we need to stream the responses, and security is a non-negotiable. So how do we do that? So we take our agent, we wrap it in Fast API for streaming, you package it in a Python project, create your Docker files, your Lambda stack, you build it for authentication and authorization, you make sure it versions very well, and then you deploy it. And this will work. I've done it, we've done it. And if you want to go this route, you're fine. However, if you say to me like, Andries, that is a lot of boilerplate code for a simple Strands agent. Is there another way? Yes, there is. Bedrock Agent Core. If you look at the right-hand side of the slide, in its simplest form, what you can do, you can bring your agent into the Agent Core runtime by wrapping it into an invoke Python method. And you decorate that method with an app.entryPoint decorator. You test locally, as you normally would, and at some point you say, Agent Core configure on the command line. And this builds all the boilerplate code I just talked about in the previous slide. Once you're happy with that, you say Agent Core launch, and it launches it into production, into your Amazon environment. So it's very easy for CI/CD integration, even more brilliant for rapid prototyping. If you go this route, you benefit from all the other Agent Core services that it offers, that Amanda spoke about earlier on. So how does the architecture look like? Simple. We take the services as native as possible, no magic sauce. So in the middle here we have our Agent Core agents. They have access to foundation models, guardrails, memories, knowledge bases. We use knowledge bases, RAGs as a service, Bedrock knowledge bases, to obtain our regulatory information, tools. And then we got two sets of apps. We got in-house apps we develop ourselves and third-party apps. The in-house apps we host on Amplify hosting with Cognito user pools federated to Active Directory, Cognito identity pools. We obtain temporary STS access keys. And this gives you direct access to the Amazon APIs, in this case, Invoke Agent. That is really powerful. Third-party applications that do not have the capability to access STS tokens, we just put an API gateway in between. It's a bit more effort, but well worth the compromise. If you look at the overall picture on how we do this, we basically host our AI architecture in two accounts, in pre-production and production. Not different than any other application we host in our environment. And it is surrounded by what we in our normal multi-account architecture that takes care of security, compliance, monitoring, and networking. Okay, my last slide. Before I hand you back over to Amanda. The lessons we learned in this path of Gen AI in Holland Casino is that AWS democratizes the use of Gen AI. You do not have to study 4 years at a university in order to create well-crafted, stable, and scalable AI architectures. So you can keep your DevOps methods. You can keep on investing in your current AWS knowledge, especially Bedrock and Bedrock Agent Core. Now, this is important. These are the tips I was speaking about. That's why we placed it also in the box, right? Expect non-deterministic behavior of your agents and mitigate the risks. And here are some of our tips. Fine-tune your system prompt of your agent. Really important. Give very clear instructions. Give the do's and the don'ts, and give a very clear output format. That is really important. You combine this with Bedrock guardrails. Then, agents must focus on one thing and do this very well. When I had my first agent, I got very excited. I uploaded all the tools that I had, so one agent to rule them all. The agent did not perform. Why? Because my tool specs were not really specific. And the model struggled to select the correct tool, right? So make sure that if you need to use a lot of tools, make sure that you're very clear in tool specification. Make sure that the tool specification don't overlap with each other so that the model can select the right tool. If you set up knowledge bases, what you must do is you must invest in very realistic evaluation jobs. And you can use Bedrock for that as well. They give you very nice metrics. Especially if your knowledge base is in flux, when the data changes all the time, or when your agents start using different models, you need to rerun your evaluation jobs. And the last one, and that one is very simple but very important, make sure that your end users have a very easy way of giving you feedback of your agents in production. Thank you. That's it for me. I'll hand you back over to Amanda.
Thank you, Andres. Thanks for sharing the Holland Casino. So, all right, guys, some final thoughts, and thank you guys for staying by the end. It's a lot of content here. In summary, we can use AI to accelerate regulatory compliances. Sicoob demonstrated how we can do this on top of infrastructure using AKS, and Holland Casino with Andres showed us how they developed this using Strands Agents. Okay, so there is a bunch of different paths to follow, but you can achieve your regulatory needs using generative AI on AWS. All right. Where do I start? That will depend. That's the architecture answer for all the questions. You can start with a compliant foundation, so you need to have a standardized foundation for run your workloads on AWS. Select your models as we discussed here. Build your agents the way that works better for you, and then deploy it in production in AWS with your regulatory needs. Okay. Here are some resources. So this is the first day of the event. I hope you guys are enjoying the event. There are some resources here from the both perspectives that we discussed, both with infrastructures and with Amazon Bedrock. I will wait for you guys to take the photo. Okay. Some sessions to watch at re:Invent. So saying again, this is the first day of the event, so you're going to have a lot of different contents here with our colleagues from AWS. You can take the pictures too. Okay. Thank you all. Thank you for joining us. Thank you for watching, staying by the end. And I would like to also ask for you guys to go into the app and say if you like the presentation or don't. If you have any questions, we will be outside of the stage from, I don't know, maybe 5 or 10 minutes, okay? Thank you guys and have a great event.